always a pleasure. God bless you and your family. 0737.
Now I've shown you 2 videos of the CP-2000 already, so I'm just gonna stay to the basics for this video. What I wanted to show you today is the BC-2000 bass console that was also sold as an option for this radio, and this was also made by Communications Power Incorporated, or as it is more known, CPI. It's an interesting piece of equipment, and I'll tell you now, it's multiple functions in one box. The first one jumps out right away. We got a clock, pretty accurate. So that is a nice thing to have. This one is all okay. Shows all the segments of the display okay. The other thing that's in here is a frequency counter that really counts the local oscillator, the synthesizer frequency from this radio, and then automatically adds the IF frequency to it. And then the result is that you see the actual operating frequency. Here is the frequency. We are currently at channel 38, which is indeed 27285. If I would adjust the clarifier, you can see the frequency changing. So this allows you to nicely tune in, but also to check to what extent the other station is off frequency, if you wanted to check that. So there's a frequency counter in here. Now the counter is, as I told you, compensated for the IF frequency of the CP-2000. If I turn that radio off, the counter defaults to 10.2, which is the IF frequency for the CP-2000. So the IF plus the local oscillator equals the operating frequency. Now I can turn that off. If I turn this off, I really have 0. There is a switch at the back. So now I can use it as a direct counter. So if you wanted to use this as a counter for other equipment, you can do that. So turn on the radio again. Then obviously the frequency is off now. Now you see the actual local oscillator frequency of the radio, which is what it's really counting. And if I turn on the offset, I am at the operating frequency again. So I can do that. There is an F1, F2. It compensates for 3 kHz. Must have something to do with single sideband. It's not needed because for CB, the carrier does not change when you switch from lower to upper in the 27 MHz frequency, that is. So I don't know why that's there, but just leave it as F1 and you get the right frequency. Power on off, that's clear. When you turn it off, it still keeps the clock running, and also the time base keeps running, so that doesn't drift. That's kind of nice. It uses hardly any power, but it prevents these units from drifting when you turn it on again, because it's already warmed up. So that's a feature. Then we have a built-in antenna tuner and the option to switch between 2 antennas. I can do that on the back. Now I'm on antenna 2, which is not connected to my radio. Now I'm back to antenna 1 again. And there is a built-in antenna tuner. This is not an adjustment for antenna 2 and this for antenna 1. Both adjustments are valid when you use the unit, either for antenna 1 and antenna 2. Here we have the tuner on. So now I have the tuner on. I'll show you later how that works. A nice indicator for that. Then there is a preamp, and I will let you hear that. This is the radio. Now I have the preamp on. You can see in the S meter what that does. Preamp off, preamp on, off, on. Now, in all fairness, where I live, I got a very high noise level from above ground power wiring. So the noise is already on the high side, and all this unit does is amplifying that. So I do not get any improvement in signal to noise ratio where I live. So for me this is basically useless. The radio is sensitive enough by itself. All it does is turn up, boost the S meter, and the volume goes up a bit in terms of the noise. But it does not help me in getting a better signal to noise ratio. But if you live in a very quiet environment, you know, outdoors, far away from all noise sources, then adding this 10 dB gain for the receiver amplifier, for the RF amplifier and the receiver, would make it possible to pull out some very weak stations. But my problem is where I live, those weak stations are already drowned out in the noise, and adding gain to it is not going to help that. So this might help some people that live away from noise. It doesn't work for me, but it's there nevertheless. There is relays in there that switch that receiver in, that receiver amplifier during receive. Obviously when you transmit, because the wiring is looped through, I'll show you that later and I show you the rear of this unit. When you transmit, it needs to be taken out of the circuit, and for that there is a couple of relays, which we'll see when we open up the unit. The relays can fall off quickly or slow. So when you are on amplitude modulation, you want the relays to fall off quickly. When you are in single sideband, you don't want that, because then you would hear the relay click constantly as you're talking, clickerty clickerty click. That will drive you crazy. So when you turn the SSB mode on, the switch in SSB position, then you delay that a little bit, and it will basically add some hysteresis. That's really what to call it. And then you won't be constantly bothered by that nervous clicking noise. Now again, that's only important when you have the preamp on. If you don't use it, then this is not of importance either. So that's basically the features of this unit: antenna tuner, antenna switch, frequency counter, time clock, RF preamplifier. That's what this unit does. This particular one still has the original label on there that CPI used to put on their products, and the unit is in like new condition actually. It runs off 120 volts AC, and that's also where it gets the time base for the clock. So it doesn't use the crystal oscillator for the clock, it uses the 60 Hertz. So it is important that you keep it plugged in if you want to have the clock be accurate. Alright, let's have a look at the back. Here we are at the rear sides of the equipment. Here is the station control, and here is the radio. Let's start with the hookup. The output of the local oscillator that I told you, this is standard on the CP-2000. I did not modify that, that is already there. That goes through this cable to the input of the counter, so that's a 1-to-1. Then of course we have the output of the RF jack, goes to the input of the unit. It basically says transceiver, so you can't go wrong there. And then we have the output, which can either be switched between antenna output 1 or 2. And I have it at 1, I have nothing connected to 2. This is the switch that toggles that. And that also made that LED on the front go left or right, remember. Then here we have our switches for setting the clock. The clock can be set for 12-hour format or 24-hour format, so that's military versus normal, if you want to call it that. This is to set the clock. You can advance fast or slow. And this is that switch I was telling you about, that you can either use it as a external counter or as a counter to work with this radio, so it will show the proper frequency at all times. So basically it says preset that 10.2 megahertz. Remember I told you about that? That is what we have set now. So it creates the offset, so I see the right frequency when I measure, when I count the output of the local oscillator for the CP-2000. If I do direct, then I can use the counter as a direct counter with this as the input, For instance, let's say you have another CB radio and you want to see what the frequency is if that's, you know, the carrier is correct. You just put the output in here through an attenuator. So don't put the transmitter output directly into here. You will destroy the unit. But you have to put at least 30 to 40 dB attenuation in here, and then you will be able to measure the frequency of that radio. But then you have to put this in the direct mode. This is an RF sample. For instance, if you have another counter, if you want to test the output power, the output frequency of whatever you put in here, you can use this output. So let's say you use this unit with a totally different CB radio. Then this goes to the CB radio. This gives you your antenna switch and your antenna tuner for either connector 1 or 2, RF output 1 or 2. Then you would hook up the RF sample output to here, so you don't need the attenuator, because you only need a little bit of power going into the counter, and you don't want to destroy anything. So instead of using an attenuator, if you use the unit itself, take a little bit of the RF power through the RF sample output, put it directly in here with the loop, and you can measure the frequency of that radio, but only during transmit, of course. In this setup, you can also see the frequency during receive. That's basically the back. Okay, I forgot one thing. You can either hook it up to DC or AC. I have it up to AC now. If you connect it to DC, the counter and everything will work, but the clock won't, because remember what I told you earlier, it uses the 60 Hertz frequency from the mains to as a time base for the clock. So if you use DC, the clock won't work, everything else will work fine. But like I said, I have it running off AC. Alright, I took off the power, the AC power, and we're going to have a look at the inside. Took the screws off the case. And this is what we have on the inside of this unit. Pretty straightforward. Here are the 3 switches I showed you earlier. This is actually the counter board and the clock board. This integrated circuit is basically the time clock. And everything here, this is the time base for the counter, the gated. It creates the gate for the gating for the counter. These are the latches and the actual counters. This is the power supply for the whole thing. Like I said, it runs off AC. You see that here. This is where the fuse is. And then it's rectified and stabilized by a regulator. I'll show you that in a minute. It's on the other side. This is the time-based crystal for the counter, not for the clock, for the counter. And like I said, when you turn the whole thing off, that will still stay powered, so there is no drift when you turn it on. This is the display unit, and here are the front switches. In a very nice condition. Now here, I did repair the unit. It needed 2 new integrated circuits there in the counter circuit. Now that was professionally done with a temperature control iron. All the flux was removed after soldering, and well, I used sockets. If it ever goes wrong again, you can just take them out, put other in there. That's the only reason why you can see it's being repaired. It was repaired, but had I not done that, you would not have seen that this unit was ever repaired, because I solder better than anyone else. No reason to be, no reason to do false modesty. I've been repairing radios for 30 years. Nobody is better at it than I am. And they used to do the same thing. If you repair anything, the trick is not to make things too hot. So always use a temperature controlled iron, and use lots of flux and clean that afterwards. Then you can also do a professional job. Alright, let's look at the other side. Enough chest thumping. And here you see the bottom side. This is the regulator I was telling you about, 5-volt regulator, pulled on the chassis. Here are the connectors, the A and B and the antenna switch. And here is the antenna tuner. These are 2 relays. One is to turn the antenna tuner on or off. The other one is to have the RF amplifier, the receiver preamp, either on or off. And this is the preamp. And these are the 2 tune circuits for that, on 27 MHz obviously. And here's the antenna tuner. And these are the two variable capacitors for that. Now the antenna tuner, like I said, can either be turned in or out with this relay, which is controlled from the front. And it does it such that both capacitors are still used, whether you use antenna A or B, 1 or 2. That doesn't make any difference. This is the lighting for that. Put an LED in there. The original lamp was still good, the light bulb was still good, but this way it will last you forever. And this is one of those one that mimic the color of a real light bulb. So it's not one of those nasty purple LEDs. This is the latest soft bright that mimics that light real good. Okay. Antenna tuner, amplifier, regulator. And that's basically the bottom of our unit. Alright, I wanted to show you the counter as a direct frequency counter. So now I have the offset off. I had the ham radio here, 27898, and I have the output of the transmitter from this radio going through a 30 dB attenuator, and that then goes into the counter on the back. So like I said, we have 27898 here. If I press the button, I get 2789803. If I change the frequency on the radio, that goes as well. Now the counter can use other frequencies than just 27 megahertz. For instance, when I go to 28450, that is in the 10 meter band. 28450.003, and the counter goes as high. I tested it out earlier. 35 is still possible. It's specified for 30 megahertz, but I have it at 35265 here. Alright, and I get 3526505. That's, I shouldn't talk. That is about the maximum. If you go higher, then it starts to miss counts. What we can do is go to a considerably lower frequency, 18.1. That's a 17 meter band. 18.1. If I go to, let's go much lower. This is the 160 meter band, just above the AM broadcast band, 1.8. As you see, it does that too. So you can use this machine as a generic counter, but always be aware that you should not put the output of the transmitter directly into the counter. You know, this radio is only 4 watts. I have it in 1 watt right now. If you would use this with a CB radio, then you can use that sample output I was talking about earlier. You know, it has a sample output. You can loop that directly back into the counter. Then you don't need an attenuator, because most people might not have that. A CB radio has more power than this radio, so that will work. If I would do that with this radio, I don't get enough signal going into the counter. I tried it earlier, so that's why I'm using a attenuator right now. So if you have another CB radio that you want to use with this counter, then you can just use that sample output, and it will just directly give you your frequency. Works very nice. Okay, let's show you the function of the antenna tuner in the BC-2000. Let's go to an empty channel here. By the way, you do see the frequency change with the channels. I didn't show you that earlier. Alright, so channel 30 looks pretty clear. So what I will do is go to AM, calibrate the S meter, a little bit less noise there, calibrate the S meter. Let's see, oops, how do you do that? Here we go. Alright, S meter is now calibrated. This is my S meter read. Now it is pretty good already. What I can do is deliberately detune the antenna a bit. Hang on. Alright. I detuned the antenna a bit. So this is now my VSWR is pretty bad. So now we're gonna turn in the antenna tuner, and I'm going to adjust that. Alright, with the two knobs here. So I'll give you the clear view here. Okay. Gotta search a little bit. There we are. Okay. And there we are. Okay, now I have tuned my VSWR with the antenna tuner, with two knobs here, to 1-to-1. That's basically how the antenna tuner works. This is power indicator. This is the VSWR, the standing wave. If I turn the tuner off, I'm gonna get my bad VSWR back again. On, off. So that's how that works. You can basically, if you have a shitty antenna, pardon my French, with this you can correct for that, so you have maximum power transfer from the radio into the antenna system. And the match box, that's really what it is, impedance match box inside this unit, make sure that you can set it for a good VSWR, so that your radio PA does not suffer all that power coming back. And that's what that does. Antenna tuner. Okay, that was really it. The BC-2000 station control for the CP-2000 ham radio, CB radio, and makes a perfect match if you want to complete your CP-2000 that you already have. This is the one to get. This particular one is like came out of a time capsule. Now this CP-2000 I will put on eBay later, but for now this video was really about the station control. Thank you for watching this video.